Hello and welcome back. I'm John, an old YouTuber and PC gamer. I start to get tired. It's 5 p.m. I did find a new one. List of semiconductor scale examples. I put somewhere there. But I have the next one ready, the NS32000. But let's drink some cola and more videos uploading. But every time I'm getting a small break and I'm charging this camcorder. So actually I think we got a lot of power on this camcorder. If I could finish this six computer chips, I actually think I would like to read about Ukraine, the country Ukraine, because every day, the last 82 days I made a video, Dennis, about the war in Ukraine, and I don't know much about Ukraine, I don't know much about Russia. So I start to get tired, but so maybe I should just watch a little bit Netflix or play GTA 5. Just stop a little bit early today, then just continue tomorrow. Yes, I had to spend a few hours to copy 200 gigabyte from my external hard drive is full, but I think I will get my external hard drive tomorrow, because I got some mail. Let's put one more there. I've got so much garbage so I can barely stretch my hand into there. No, let's put one more cola. That's my water bottle. So let's do that. Let's make some fresh waters. So today I did put away all my 3X large t-shirts. This is 2X large. I have to buy like 20 2X large t-shirts I did buy like 3 years ago. When I borrow a lot of money, I did buy like 50 t-shirts this summer 2019. So of course I lost more than 20 kilos of weight. Then my t-shirt was looking weird. So I did spend half an hour today to do that. And I record that in video on Dennis. Yes, cheers. But I got that shower and shaving today, and I did find this 22X large t-shirts was in this box, so I put my 3X large, I put there. Then I have all my 2X large t-shirts down there. Then I have cleaned up a little bit here, so I can sit here. But this bed is for the garbage. This bed is totally broken. It's totally broken below here too. So this bed is just for garbage. That's another handkerchief. I don't know what that's, underwear, and my socks. That's some comics. That's some small change. But I could lay here and read if I needed. But I was thinking about should be a bed for guest beds. I had 4 bits. I have another bit there a few years ago, and I have even a bit there. I had 4 bits. But it's 5 p.m. This is 9 pages, so I think that would be 2 parts. Now record soon, 6 minutes. Yes, but I like to read about this computer chips. So I never tried that. That's the first time I try this. But I have to get used all this technical English. So that's very helpful. That's very helpful to have a computer voice. Read it loud. Let's read to end of documents.
NS32000. The NS32000, sometimes known as the 32K, is a series of microprocessors produced by National Semiconductor. The first member of the family came to market in 1982, briefly known as the 16032 before becoming the 32016.1. It was the first 32-bit general-purpose microprocessor on the market. The Motorola 68000 could process 32-bit data and use 32-bit addresses but had a 16-bit ALU, too, whereas the 32000 series was described in 1983 as the only microprocessor available at that time with 32-bit internal data paths armed ALU.3. However, the 32016 contained a large number of bugs and often could not be run at its rated speed. These problems, and the presence of the similar Motorola 68000 which had been available since 1980, led to little use in the market. Several improved versions followed, including 1985's 32032 which was essentially a bug-fixed 32016 with an external 32-bit data bus. While it offered about 50% better speed than the 32016, it was outperformed by 32-bit Motorola 68020, released a year prior. The 32532, released in 1987, outperformed the contemporary Motorola 68030 by almost 2 times. But by this time most interest in microprocessors had turned to ISC platforms and this otherwise excellent design saw almost no use as well. National was working on further improvements in the 32732, but eventually gave up attempting to compete the Central Processing Unit, CPU, space. Instead, the basic 32000 architecture was combined with several support systems and relaunched as the Swordfish microcontroller. This had some success in the market before it was replaced by the compact ISC architecture in mid-1990s. Contents. Design concept. Architecture. 32016. 32032. 32332, 32532. Swordfish. Others. Machines using the NS32000 series. Legacy. References. External links. Design concept. The NS32000 series traces its history to an effort by National Semiconductor to produce a single-chip implementation of the VAX11 architecture. 4. The VAX is well known for its highly orthogonal instruction set architecture, ISA, in which any instruction can be applied to any data. For instance, an ADD instruction might add the contents of 2 processor registers, or 1 register against a value in memory. 2. NS32008 microprocessor values in memory, or use the register as an offset against an address. This flexibility was considered the paragon of design in the era of complex instruction set computers. CISC. 3. National took December to court in California to ensure the legality of design. But when December had the lawsuit moved to Massachusetts, December's home state, the lawsuit was dropped and the Series 32000 architecture was developed instead. Although the new instruction set architecture was not VAX11 compatible, it did retain its highly orthogonal design philosophy. That is, every instruction could be used with any type of data. Articles of the time also referred to this as symmetrical. 3. The original processor family consisted of the NS16032 CPU and a NS16C032 low-power variant, both having a 16-bit data path and so requiring 2 machine cycles to load a single 32-bit word. Both could burst with the NS16082 memory management unit, which provided 24-bit virtual memory support for up to 16 MB physical memory. The NS16008 was a cut-down version with an 8-bit external data path and no virtual memory support, which had a reduced pin count and was thus somewhat easier to implement. 3. At the same time, National also announced 2 future versions, the NS32032 and NS32132. The former was essentially a version of the NS16032 with a 32-bit external data bus, allowing it to read data at twice F rate. This was projected to be released in 1984. The NS32132 was a version with a 29-bit internal addresses and 32-bit external, allowing it to address a complete 4 GB of memory. It was to be released in 1985. 3. All of these could also be used with the NS16081 floating point unit. 3. Architecture. NS32000 registers 31.23. 15. 07. 00. Bit position. General registers R0 register 0 R1 register 1 R2 register 2 R3 register 3 R4 register 4 R5 register 5 R6 register 6 R7 register. The processors have 8 general-purpose 32-byte registers, plus a series of special-purpose registers frame pointer, stack pointer, 1 each for user and supervisor modes. Static base register, for referencing global variables. Link base register for dynamically linked modules, object orientation. Program counter. A typical processor status register, with a low-order user byte and a high-order system byte. Additional system registers not listed. The instruction set is very much in the CISC model with 2 operand instructions, memory-to-memory operations, flexible addressing modes, and variable length byte-aligned instruction encoding. Addressing modes can involve up to 2 displacements and ternary indirections per operand as well as scaled. 7 index registers 00000000 SP1 stack pointer, user, 00000000 SP0 stack pointer, interrupt, 00000000 static base 00000000 framey pointer 00000000 int base interrupt base program counter 00000000 program counter MOD modulate scripter. Program status register 1511413120706050403030201000. Bit position, Ipson's LTCPSR. 23 bytes. The actual number of instructions is much lower than that of contemporary RISC processors. Indexing, making the longest conceivable instruction unlike some other processors, auto-increment of the base register is not provided, The only exception is a top-of-stack addressing modes that pop sources and push destinations. Uniquely, the size of the displacement is encoded in its most significant bits 0, 10 and 11 preceded 7, 14 and 30-bit signer displacements. Although the processor's area otherwise consistently little-endian, displacements in the instruction stream are stored in big-endian order. General-purpose operands are specified using a 5-bit field. To this can be added an index byte, specifying index register and 5-bit base address, and up to 2 variable length displacements per operand. 32016. The first chip in the series was originally referred to as the 16032, but later renamed 32016 to emphasize its 32-bit internals. This contrasts it with its primary competitor in this space, 1979's Motorola 68000 68K. The 68K used 32-bit instructions and registers, but its arithmetic logic unit, ALU, which controls much of the overall processing task, was only 16-bit. This meant it had to cycle 32-bit data through the ALU twice to complete an operation. In contrast, the NS32000 has a 32-bit ALU, so that 16-bit and 32-byte instructions take the same time to complete. The 32016 first shipped in 1982 in a 46-pin DIP package. It may have been the first 32-bit chip to reach mass production and sale, at least according to National's marketing. In a report in a June 1983 publication, however, it was remarked that National was promising production quantities this summer of 16032 parts, having been shipping sample quantities for several months, with the floating point coprocessor sampling this month. 5. Although a 1982 introduction post-dates the 68K by about 2 years, the 68K was not yet being widely used in the market, and the 32016 generated significant interest. Unfortunately, the early versions were filled with bugs and could rarely be run at its rated speed. By 1984, after 2 years, the errata list still contained items specifying uncontrollable conditions that would result in the processor coming to a halt, forcing a reset. The original product roadmap envisaged 6 MHz and 10 MHz parts during 1983 and 12 MHz and 14 EMS parts during 1984. 3. However, press reports in 1984 indicated difficulties in keeping to this roadmap, with it reportedly having taken 5 months to increase the frequency of the parts from 6 MHz to 8 MHz, and with representatives estimating a further 2, 3 or 5 months to increase the frequency to 10 MHz. 2 unspecified chips of the 5 in the chipset were reported to be the cause of these problems. 6. An early 1985 article about the 32016-based Whitechapel MG1 workstation noted that the 32081 memory management unit was suffering from bugs and had been situated on its own board, providing hardware fixes. 7. In 1986, Texas Instruments announced a fully qualified 10 MHz T32000 32-bit microprocessor chipset consisting of the T32016 CPU and T32082 memory management unit as 48-pin devices, the TI32201 timing control unit and T32081 floating point unit as 24-pin devices, and the T32202 interrupt control unit as a 40-pin device, with the 5-device chipset priced at $289 in 100-unit quantities. 8. National changed its design methodology to make it possible to get the part into production, and a design system based on the language Z was co-developed with the University of Tel Aviv, close to the NSC Design Center in Hurriya, Israel. The Z language is similar to today's Verilog and VHDL, but has a Pascal-like syntax and is optimized for two-phase clock designs. However, by the times the fruit of PC